Let's consider the set 1, 3, and 4. And let's consider all sums of two not necessarily distinct elements from the set. So 1 plus 1 is 2, 1 plus 3 is 4, 1 plus 4 is 5, 3 plus 3 is 6, 3 plus 4 is 7, and 4 plus 4 is 8. And let's play the same game with a different set. So maybe 1, 3, and 5. The set 1, 3, 1, 3, and 5. And let's play the same game. We're going to list out all sums of two not necessarily distinct elements from this set. And we're going to have 1 plus 1 is 2, 1 plus 3 is 4, 1 plus 5 is 6, 3 plus 3 is 6, 3 plus 5 is 8, and 5 plus 5 is 10. And notice over here in red, 6 appears twice. Oh, 6 appears twice. Whereas over here, every single sum is unique. Every single sum is unique. In this set, in all sets that have this property, where when you consider all sums of two not necessarily distinct elements from that set, and all those sums are unique, then we call such a set a Sidon set. A Sidon set. So let's formalize this definition of a Sidon set. So let S be a subset of the natural numbers up to n. So note that this notation means the set containing 1, 2, all the way up to n. And define the following set for each integer n. So, and for each integer n, define S sub n to be the set of all pairs A1, A2 in S cross S, so A1 and A2 are both in S, such that A1 plus A2 is equal to n, and A1 is at most A2. So, S is a Sidon set, if for each integer n, the size of S sub n is at most 1. So for instance, if we called this set up here T, then T sub 6 would be 3, 3 and 1, 5. These two pairs right here. And therefore, since the size of T is sub 6 is strictly greater than 1, this implies that T is not a Sidon set. In fact, any set that contains 3 or more terms in arithmetic progression is not a Sidon set. Because if a set contains 3 or more terms in arithmetic progression, then there's 3 terms of the form A plus D, and A plus 2D, where D is the common difference in this arithmetic progression that contains 3 or more terms. And if you add the first term plus the last term, or the first term plus A plus 2D, then you get 2A plus 2D. And if you add this term with itself, then you get 2A plus 2D. So if you call this set that contains 3 or more terms in arithmetic progression S, then S sub A, or 2A plus 2D, the size of this set, where this notation is defined as above, is greater than 1, is strictly greater than 1. So thus, S cannot be a Sidon set.